Hey there, and welcome! Today, we are diving deep into a really fascinating topic, anatomical variation. We're going to explore why the whole idea of a single, normal body is basically a myth in biology. Let's jump right in.
So, right off the bat, I want you to think about something. What does a perfectly normal body actually look like? Seriously, picture one in your head. What do you see? And what about all the stuff on the inside? The organs, the bones. As you're about to see, the real answer to that question is way more complex and, frankly, way more interesting than you might think.
All right, in this first part, we're going to challenge everything you thought you knew about standard anatomy. Because it turns out that all those little differences between us aren't the exceptions to the rule. They are the rule. So let's get a clear definition. What exactly is anatomical variation? Well, it's all the differences in our physical structures that just naturally happen between people. And the science on this is crystal clear. This is not some rare, quirky thing. It is the absolute fundamental rule of biology. This little comparison here really drives the point home. You see, a constant finding in anatomy, that's a part of the body that's pretty much identical in every single person, is incredibly, incredibly rare. What's actually the norm, the standard state of things, is variation. The big takeaway? Being different is what's normal.
Okay, so if everybody's so different, how do our bodies even manage to work? It seems like it would be chaos, right? Well, it turns out that despite all this variation, our bodies are all built using a shared set of basic blueprints. Let's check out the 4 main principles of how we're put together.
And here they are: zygomorphism, metamorphism, tabulation, and stratification. Now, I know these are some pretty fancy-sounding words, but trust me, the ideas behind them are actually super simple and elegant. These are basically the ground rules for building a body. First up is zygomorphism. All this really means is bilateral symmetry. If you were to draw a line right down your middle, your left and right sides are almost mirror images of each other. You've got 2 ears, 2 eyes, 2 arms, but it's almost never perfect. Just think about your heart. It's sitting mostly on your left side, totally breaking that perfect symmetry right from the get-go. Next, we have metamerism. This is the principle of serial repetition. It's the idea that our bodies are built with repeating segments, almost like links in a chain. The easiest way to picture this is to think of your spine. It's just a stack of similar bones, the vertebrae, one after another. Your ribs are the same deal. And these last 2 principles, they really go together. Tabulation is this tube within a tube body plan. Your digestive tract, from your mouth all the way down, is basically one long tube running inside the bigger tube of your body. And stratification is just layering. It means we're built from the outside in, kind of like an onion. You've got skin, then fat, then muscle, and finally bone. Okay, so we've got the blueprints, but what's actually responsible for writing all the unique details for each and every one of us? What causes all this amazing variety? Let's take a look at the key factors that are driving all this difference. Well, the research points to a few major players. Things like your age, your sex, your genetic background, and your individual body type, your constitution. They all play a huge role. And kind of overseeing all of this is the grand force of evolution, which has been shaping and tweaking these variations for millions of years. I absolutely love this quote. It nails the effect of age so perfectly. You see, a baby isn't just a shrunken down adult. The proportions are totally different. The head is massive compared to the body, the legs are short. Our bodies are in a constant state of change from the moment we're born. And of course, the other factors are just as important. Your biological sex influences things like your bone structure. Your genetic heritage, what the text calls race in humans or breed in animals, can influence all sorts of features. And your own personal constitution or biotype is what makes your physical makeup unique. It's the combination of all these things that makes you you. So this leads us to a really tricky and fascinating question. If there's so much variation out there, how in the world do scientists and doctors decide what's normal versus what's just an unusual difference, an anomaly, and what's something more severe? Where do they draw those lines? This breaks it down really well. Generally, normal is just what's most common statistically, and this is key, what works correctly. An anomaly, on the other hand, is a pretty big deviation from that common pattern, and it's often, though not always, linked to some kind of problem with function. A cleft palate is a classic example that can affect how someone eats or speaks.
And you should know, these aren't just some vague ideas. They are actually written down, defined, and debated in foundational scientific books. It's in texts just like this one, where the scientific community works to establish the standards they use to classify the whole incredible spectrum of life.
So here's the bottom line. The word normal itself is actually pretty flexible. Does it mean what's most common? Does it mean what works the best? Or is it some kind of theoretical ideal? The truth is, it can mean any of those things depending on the context. The lines can get very, very blurry.
So, let's wrap this all up. Why should we even care about any of this? Why does understanding anatomical variation actually matter in the real world? Well, as it turns out, it's pretty much everything. Yeah, this isn't just some neat piece of biological trivia. Getting your head around the fact that variation is the rule is absolutely essential to how we practice medicine, how we understand biology, and honestly, how we should see each other. Just think about it for a second. A surgeon can't just assume that a patient's blood vessels are in the textbook location. They have to be ready for variations to operate safely. A radiologist needs to know the whole range of what a normal kidney looks like to be able to spot one that's actually diseased. And for evolution, variation is literally the raw material that natural selection works with. In veterinary science, this is obvious, right? You can't treat a tiny chihuahua the same way you'd treat a massive Great Dane. Which brings us right back to where we started, but now with a totally new way of looking at it. If every single one of our bodies is a unique take on a set of blueprints, a one-of-a-kind masterpiece, then does the idea of a single, ideal, or perfect body even make any sense at all? Definitely something to think about. Thanks so much for joining me today.